Today we will be performing an experiment to determine the coefficient of discharge of an obstruction flow meter. That means we can find it for venturi meter or orifice meter. So for that we are having the apparatus by the name of venturi meter and orifice meter, specially designed for this experiment. We need measuring tape, we need a stopwatch. Now students, I will take you to the setup and explain you various parts of it, and then we will take one reading there, and after that we will come back and do the calculation work here. Student, this is our flow measurement apparatus, or you can say venturi meter oblique orifice meter apparatus. Now this setup or apparatus consists of our 25 mm dia pipe circuit. You can see here, and there is a common header, and there are two pipes there, and on each pipe there is flow meter. On one pipe there is an orifice meter, and on another pipe there is a venturi meter. Now here the dia of the throat in case of venturi meter is 1.5, and here in case of orifice meter the dia of the orifice is 1.5. Now in this setup what we are doing, we are taking two measurements. What are those? First one is your pressure drop measurement. Pressure drop measurement will be taken with the help of this U-tube mercury manometer, and second flow measurement will be taken with the help of this tank. And the method is very similar to what we have done in other experiments. Now I am switching on my apparatus, and I will take one reading corresponding to venturi meter and show you how to take the readings, and after that we will move to the observation table and do the calculation there. Students, now I have switched on my apparatus and I have chosen venturi meter. Okay, so the flow is only taking place through this venturi meter pipe. There is no flow taking place through this orifice meter pipe. Now first of all we will take the flow reading. Now what is here? The initial level is already maintained to 2.5. Now as we have done in another experiment also, now I will be diverting this valve and measuring how much flow is coming in 10 seconds. So I have switched on my meter stopwatch. And in 10 seconds, now the level has risen to 10 centimeters. So initial level is 2.5 and the final level is 10 centimeters. The area of the tank here is 40 by 40. So coming to the pressure reading. So venturi meter, for venturi meter I am sitting on the wall, and the reflection has occurred on the left rim. The reading is 24.3, and on the right rim the reading is 5.4. So on the left rim the reading is 24.3, and on the right it is 5.4. Now we will move to the observation table and do the calculation there. Student, coming to the observation and calculation part, now you have noted down in case of discharge measurement, initial level was 2.5, final level is 10 centimeter, time taken to rise the level is 10 seconds. So the discharge will come out to be 1200 centimeter cube per second. Now in your head loss readings, you have noted down the left limb was 24.3, the right limb is 5.4. Now using these observations, if you find out the value of the head loss in terms of water, it will come out to be 238.14. Now coming to the main part is to calculate the coefficient of discharge in case of a venturi meter. Now for this you will be using this formula of the flow rate for venturi meter. You have seen this formula in case of theory class. Q is equal to CD small a under root of 2G delta H whole divided by under root of 1 minus small a upon capital A raised to power 2. Now in this, your small a is the area of cross section of the throat. Capital A is the area of cross section of the inlet pipe. Now if you substitute the values, that is for the calculation of CD, you need to have the value of Q. You need to have the value of small a. You need to have the value of G, delta H. Now, if you substitute all these values in this formula, you can calculate your CD. Now you can see we have calculated the Q. Q you have calculated, it comes out to be 1200 centimeter cube per second. You have calculated delta H, which will come out, which we have seen it is 238.14. Small a, you know it is 1.766 centimeter scale. Capital A, it is 4.90 centimeter scale. If you substitute all these values here, you can calculate your CD. Now, if you substitute all these values, CD will come out to be 0.931. So similarly, you can take number of runs. You can rate 2-3 runs, and for different flow rates, you can calculate your CD. And for calculating average, you can add them and divide it by the number of turns you have done this experiment. That will give you the average value of coefficient of discharge for this venturi meter. Similarly, if you are interested in calculating for the orifice meter, you can use the same setup to calculate the coefficient of discharge for the orifice meter. Thank you.